1 2 3 check, testing, testing, 1 2 3 1 2 3 testing, check, 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 1 2 3. Can you hear me? Can you hear me? Check. 1 2 3 1 2 3 testing, testing, 1 2 3 1 2 3 check, check. Mic testing, Zoom mic testing, check, 1 2 3 1 2 3 check, 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 1 2 3 testing, 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 1 2 3 mic testing, 1 2 3. Yeah.
So if you don't know, can we have the hotspot?
Hotspot on Ubuntu, I don't know how you can see. There's no option of in Ubuntu.
Can you go through network, please? I think so. No, thanks.
Okay. All right, good morning, everybody. Morning, everyone. Perfect. All right, so yesterday you have seen the session online, I think. Anybody was here in the seminar hall yesterday? All of you saw it online? How many of you could not see it online? Not possible to see? Any technical issue you faced? What issue? Network was not working. Okay. Good. Now you're here. Network or no network, you can see properly. Okay. Okay. That time network was not working. At home, did you go and watch the video? Why? Home also network is not working. So nowhere network is working, is it? Okay. In college, network is not working. I can understand. When you go home or you go to hostel, you can still find some network. Okay. Hostel also it's not coming. If you go a little bit outside hostel, it comes. You're sitting in ground over there. Yes. For me, it's coming. So anyway, the session is online. You can watch it. Yesterday's session, it's already there online. Please go ahead and watch it. Anybody can give me recap of what all was covered yesterday's session? Please tell me. 2D list, okay. Matrix, very nice. Sorry? Taking input, okay. Boys, if you can't contribute, then keep quiet. Either you tell me, speak to me directly, or you don't speak at all. Okay? No need for talking between. Everybody has notebook with you? Show me your notebook like this, everyone. Okay, pen. Everybody has pen? Okay. A lot of people are sharing notebooks. Very nice. Right? Share notebook, write each other letters. Good, very good. Okay. So taking input, what else? Printing row wise. Okay. Everybody, if I hear any more talking apart from me, if you're talking to me, it's fine. If you're not, if you continue to talk amongst yourselves, I am for sure taking a session on Friday. I'm cancelling a freshers. Okay. Yesterday also I said the same thing. I have a lot of syllabus to cover. If you delay me anymore, I will take time on Friday. Shall I do that? Yes. A lot of people are saying yes. No? For sure? Okay. So please talk to me directly. If I see you talking amongst yourselves, I will pause the session today. I will stop it. Tomorrow you go watch online. Friday also you watch online. Because Friday I will take today's session. So I will pause today's session if I hear any more talking amongst yourselves. Okay? Alright. So transpose what else? 1D lists. Taking input. Linear search, very good. Binary search. Super. Okay. Sorry? Sorted analysis. We didn't do it. I was saying binary search can only be applied on sorted arrays. Can only be applied on sorted arrays. It's not sorted analysis. Only be applied on sorted arrays. Okay? You get up. You. Don't look at me. Get up. Get up. Yes, yes, you. You. Get up, please. You also. Your friend. Behind you. Yes, you also get up. No, not you. Yeah. Please. Come. Take them out. Take them out. Come on. Come on. Stand here, please. Stand. Both of you stand here. Keep standing there. Look at your friends. Look at your friends and keep standing. Okay? That's all. Alright. So this is what we covered yesterday. Alright? Today we will continue our session and today our topic will be on sorting. Our topic is going to be on sorting. What are the different kind of sorting algorithms that we have? You may have covered this already in your syllabus. Okay? So what are some of the sorting algorithms that we have? Can you tell me? Bubble sort, very good. Insertion sort, very nice. Selection sort, okay. Merge sort, quick sort. You know any other sort apart from this? Heard of any other sort apart from this? Radix sort, very nice. Any other sort heard apart from this? There is something called heap sort also. Okay. Now, last three or last two, we are not going to cover. It's not in our syllabus. We are not covering. But if somebody asks you, you can say, yes, there are two more sorts. Radix sort, heap sort is there. Okay, so just for your understanding. Today we look at these two, bubble sort, insertion sort, and selection sort. These three we are going to look at properly. And if time permits, merge sort and quick sort also. But we are going to look at these three sorting algorithms today. I'll also open my coding editor. Okay. So this was yesterday's code of binary search. And okay. So first we'll start with bubble sort. And even before that, let's understand what is sorting algorithm mean. Okay. What is meaning of sorting algorithm? So sorting means, let's say we talk about bubble sort. Let's say I give you the array 8, 5, 1, 3, 7, sorry, 1, 7, 2. Okay. What will be the sorted version of this array? This is the array given to you. If I want to sort the array, what will it become? 1, 2, 3, 5, 7, 8. Okay, 1, 2, 3, 5, 7, 8. Why? That is the sorting of it, sorted version. Okay, everyone. So what we are going to do is we are going to write algorithm on given a list, how to sort it. Given a particular list, how do I sort that list? Okay. So one way of doing that is like this. If I already have a list 8, 5, 1, 3, 7, 2, like this, 1, 7, 3, 2. Okay. So if I have the list in Python, I can do something like array dot sort, and my array is already sorted. Okay. This is one of the specialities of Python. I have something like this. I get automatic sorting over here. Now, if you go to interview and somebody says, can you tell me how to sort in Python? And you say, sir, I'll use dot sort. It's not wrong, but interviewer is expecting more from you. This is what we call built-in function. Built-in function. Built-in function means it's already there in Python. I don't need to write logic for it. Okay. But if we are not going to use the built-in function, we are not going to use the function already made by Python. We will have to write our own logic. So bubble sort is one such logic. There are many logic. We saw there are 5 logics like that. But bubble sort is one such logic. And we're going to look at bubble sort right now. So how bubble sort works? First, understand the logic, then we'll go to the code. Okay, so first understand the logic part and then we'll go to the code. How bubble sort works is like this. There are 6 elements here, right? If there are n elements, then we are going to repeat the process n minus 1 times. What are we going to do in that n minus 1 time? We are always going to compare adjacent elements, elements that are next to each other. We are going to compare them, and if they are in the wrong order, we are going to swap them. We are going to swap them. So, for example, in the first turn, we are going to say, let's go through the array. 8, 5. Is that in the correct order? No. So, we will swap them. It becomes 5, 8. 8, 1. Correct order? No. Swap them. 1, 8. 8, 7. Correct order? No. Swap them. 8, 3, no, swap them. 8, 2, no, swap them. So now what happens is, this was the first iteration or the first run. We will do this few more times. But in the first iteration, we stop here. Then we go to the next iteration. And we say 5 and 1, correct order? No. Swap 1, 5. 5 and 7, correct order? Yes. So don't swap, leave it as it is. 7 and 3, correct order? No. Swap? No, yeah. Swap 3, 7. 7, 2, correct order? No. Swap 2, 7. 7, 8, correct order? Yes. Actually, we don't even need to make last comparison because 8 already reached the correct place. So 7, 8, even if you compare, it will never change. What's happening is, at every time, the last element and then the second last element is reaching its correct position. 8 reached its correct position here. Now 7 and 8 reached their correct position. Let's continue. 1, 5. Okay. 5, 3. No. 5, 2. No. 2, 5. And 7, 8 already in correct position. We don't need to even compare. But even if you compare 5 and 7, already there, right? Fine. And 7 and 8 are already okay. So these three are in the correct position. Now 1 and 3, no problem. 1 and 2, sorry, 3 and 2, no. 2, 3, 5, 7, 8. Now as per computer, these 4 are sorted. Actually, the entire array got sorted. If you look at it, the entire array got sorted. But as per computer, computer doesn't know. It already got sorted. So as I said, there are 6 elements. We are going to run this 5 times. So one more time it will run. But this time there will be no swap. So 1 and 2, any need to swap? No. So it becomes 1, 2, 2 and 3 is fine. 3 and 5 is already fine. 5 and 7 already fine. 7 and 8 are already fine. So what happened is, as I said, if there are n elements, we are going to run it n minus 1 time. 1, 2, 3, 4, 5. 5 times we ran it. Okay. Maybe in middle itself the array gets sorted. But computer doesn't know. It got sorted. Right? It's not checking every time. So it will still run it. What is happening in each step? Each step it is comparing adjacent elements. Elements that are next to each other. And if they are not in order, it's going to swap them. If they are in order, no problem. Okay, don't swap. Go to the next element. Understood? Bubble sort? How it's working? Everybody understood? Let's write the code for it. So this is the array given to us. Okay. We'll write the code for bubble sort. So I want to repeat it n minus 1 time. Okay, I want to repeat it n minus 1 time. So what will I do? I'll say for I in range n minus 1 actually. Why n minus 1? Because I'm going to start at 0. Okay. I can also say range 1 to n. Both are fine. Both will repeat n minus 1 time. Okay, because it will never end at n, it's always going to stop at n minus 1. So if I start at 1, it will go till n minus 1. Okay, both are fine. So we'll go with this. For I in the range, I prefer this one. I'll go with n minus 1 like this. So it's going to go from n 0 to n minus 2. Means it's going to repeat n minus 1 time. For example, if the number is 6, okay, n minus 1 is 5. So it's going to go from 0 till 4. 0, 1, 2, 3, 4. Right? It's going to go from 0 to 4. So it's going to repeat only 5 times. Hope everybody is understanding this part. Yes? Clear? Okay. So I want to repeat n minus 1 times. This is what I did. Next, after that, what I want to do? At each step, compare adjacent element. So over here, what does it mean by comparing adjacent elements? I will compare 0 index with 1 index. If they are out of order, I will swap them. Right? Then after that, compare 1 index with 2 index, out of order, then swap them. 3 index with 4 index and then 4 index with 5 index. Or other way, I will compare 1 index with 0 index, 2 index with 1 index. So what I'll say is for j in range, what is the last index that I'm going to compare with? What will be the last index here? 5. In terms of n, what will be the last index? N minus 1. So what I'm going to do is, we'll come up with this range. Basically, I'll compare if array of j less than array of j minus 1. This means it's out of order, everybody. Array of j less than array of j minus 1 means it's out of order, because as per sorted array, array of j should be greater than array of j minus 1. Yes. Okay. So if this is the case, I have to swap. I still didn't decide my range. I'll decide my range, but I have to swap if this is the case. How to swap in Python? Simply do array of j minus 1 equals to array of j minus 1 array j. Right? This we studied about 3-4 months back. Right? How to swap in Python. Okay. Now one thing that's remaining is what has to be the range. So what will be the first pair of indexes that I will compare? I repeat, which is the first 2 indexes I will compare? What will be array j? What will be array j minus 1 in that? Can you tell me? Array j will be, what will j be, the first index? So 0 I will compare with array minus 1. What will be j and j minus 1? What will j be? Some answer, everyone. Any answer. Wrong answer is completely fine, but you have to give me some answer. Okay. What is this one doing? Tell me which number it is comparing. Forget indexes. Which number I am comparing here? First time, what number I am comparing? 8, 5. So here this array j is 8 or is it 5? 8. It's 5, no. Right? I am comparing is 5 less than 8. Then swap. I am not comparing if 8 is less than 5. If 8 is less than 5, you don't need to swap, right? Because 8 is already coming before 5. You understand? I'm comparing 5 less than 8. Clear, everybody? This part? So which index is this? Index is 1. This is index 0. Meaning j, first index j has to take is 1. I have to start from 1 and I have to go till n minus 1. So that it will compare n minus 1 with n minus 2. It's going to compare n minus 1 with n minus 2. So I'm going to say for j in range 1 till n, so that it stops at n minus 1. For loop will always stop at 1 lesser. So here what I'm doing is I'm saying for I in range j, for I in range n minus 1, repeat this n minus 1 times. Here take j from 1 to n, and if the next element is lesser than the previous element, swap it. Otherwise, leave it as it is. Finally, let's print the array over here. So let's see if it gets sorted or not. N is not defined, very good. So we'll just say n is equal to len of array. Very nice. Okay, it gets sorted, everybody. Yes, it has got sorted. Okay. This is bubble sort, everyone. You can copy it down if you want to. Please note it down. This is bubble sort. Notebook, pen. Please get it. Stand here. Get it and stand here. Anybody else wants to join them up here? If you don't want to join them up here, please keep quiet. Hmm? This part is not visible at the back. Can you come please 2 more seats ahead? Can you please come? There are 3 rows pending. No, please come ahead quickly. I can't make it bigger than this, unfortunately. It can't become bigger than that. So please come ahead. Are there some sharks? Are there some sharks or dragon or something is sitting there in that chair? What's the problem? You'll get COVID if you go there. Yeah, very good, guys. Very good. Very good. Done. Everybody wrote it down. Everybody written it. Yes. Okay. Let's go on to the. Okay. Now, one thing before we go to the next one. One thing about bubble sort. Every time after every iteration, see here the first maximum number came till the end. Then here the second maximum number came here. Then third maximum number finds its correct place. Then fourth maximum number finds its correct place. Then fifth maximum number finds its correct place, right? So in each iteration, what's happening is the particular maximum number reaches the end. Okay, that's what happens in bubble sort. Why that's happening? Just think about it. This 8 came here because anytime two number was compared, the bigger number came to the right side. Anytime the two numbers were compared, the bigger number is coming to the right side. The maximum number will always win the battle, right? So 8, because it's a maximum number, it's always winning the battle and it's always moving to the right side. Then once 8 is already on the right side, who will win the next battle? The second maximum number will win the battle. Anytime two number is compared, it is greater than all the numbers except the greatest number, which is already on the right side. You understood why this is happening? So this is bubble sort. Let's go to selection sort first, then we'll go to insertion sort. Okay. So selection sort, as the name suggests, okay, is all about selecting a particular number. It's all about selecting a particular number. How does it work? It works like this. You assume two parts of the array. One part is sorted, another part is unsorted. First part of the array is sorted. That is, left side of the array is sorted, right side is unsorted. Initially, the sorted part is completely empty. Okay, there is nothing. There is no sorted part, and all of these are unsorted. All of these are unsorted. Now, in a sorted array, which number should be the first number in a sorted array? Least number, very good. Minimum number. Okay, so this is what we're doing in selection sort. We're always picking the minimum number. This is how it works. You pick 8 and then you say, what is the minimum number on the right side? 1. Now you compare between 1 and 8, which is lesser? 1. So what you're going to do is you're going to swap them. You're going to swap them. You're going to make 1 here, 8 here, and now your 1 is in the sorted part of the array. You don't touch 1 now after this. Okay? So you have 1, 5, 8, 7, 3, 2. Now same thing, I'll hold 5. I'm holding 5. Minimum number on the right side? 2. Very good. Is 2 less than 5? Yes. So what am I going to do? Swap them. So it becomes 1, 1, 2, 8, 7, 3, 5. Very good. Now I hold 8. Minimum number on the right side? 3. Very good. Should we swap? Yes. 1, 2, 3, 7, 5. No, 7, 8, 5. Minimum number on the right side? 5. Should we swap? Yes. 1, 2, 3, 5, 8, 7. Then hold 8. Minimum number on right side? 7. 1, 2, 3, 5, 7, 8. Right? And only 8 is remaining on the right side. It's automatically sorted. Okay? This is how we take it. We'll take another example. I'll just take another example as well. Okay. Let's take a slightly changed example. You have the number 8. So what I'll do is I'm holding 8. Okay. I hold 8 here. Minimum number on the right side? 1. Right? 1 less than 8? Yes. So swap it. Becomes 1, 8. So here 8, 3, 7, 5, 2. Okay. Minimum number on right. Now hold 8 again. Minimum number on right side? 2. Swap. 1, 2, 3, 7, 5, 8. Okay. 3. Minimum number on right side? Minimum number on the right side of 3. 5 is the minimum number on the right side of 3. Should we swap it? No. So you will always choose the minimum number, but you don't always have to swap. This is why I give this example. So it becomes 1, 2, 3, 7, 5, 8. No swapping happened. Now 7. Minimum number on right side? 5. 1, 2, 3, 5, 7, 8. 7. Minimum number on right side? 8 is the minimum number on right side. But should we swap? No, we don't swap. We leave it as it is. And only 8 is remaining on the right side, which automatically it is swapped. Okay. In this sense, selection sort is kind of like the reverse of bubble sort. In bubble sort, maximum number is reaching its end. In selection sort, minimum number is reaching the start always. Okay. Always remember that by the name, bubble sort is the maximum number is being bubbled to the right side. Right? You know how like big bubbles will go first on top? So like that, the maximum number is being bubbled to the right side. In selection sort, you're always selecting the minimum from the right and pulling it here. Select the minimum from the right, pull it here. That's what's happening in selection sort. Clear everyone? Let's do the selection sort code. Okay. So what do? We are always holding a particular number and then we're searching for the minimum number on the right side. Okay. Now, quick revision. Minimum number. How do we find minimum number? Yes, min is one way. Without built-in function, how to find it? Our friend is very sleepy this time. You're very sleepy? Go wash your face. You only. Yes, you. Please get up. No, behind you. Not you, not you. If you want to wash your face, you can also wash. No, you. You know, behind you. Exactly behind you. Yes, you. You. Yes, yes, you. Please go wash your face. Nobody, you're sleeping in front of me. Go wash your face. Okay, anybody else wants to wash? Okay, what was I saying? What was I saying? Yes, selection sort, minimum number. Okay, so we were talking about selection sort, and in that we want to find the minimum number. Now pause selection sort for 2 minutes. You know, you all watch Netflix Prime Video, right? Right? So TV show you're watching, sometimes you watch 2, 3 series at same time. No? Once only till you finish one series, then only you go to next series. In parallel, you will never watch one episode of this, one episode of that. Nobody. No? How many of you watch parallelly? I finish one episode. Now instead of going to second episode, I'll finish one episode of another show. Anybody does this? Okay. I don't know why you don't do it. Many people do it. Okay. Anyways, so you are watching TV show 1, which is selection sort. I'm saying pause. We will go to episode 2 of selection sort. We will go. But before that, we need to cover one thing, which is finding minimum number. Okay. How to find minimum number? Finding minimum number. Okay. So yes, we can do the min. That you all know. I'm not talking about that. But another way of finding minimum number is, what you say is, you assume the first number to be minimum. Let's say you assume 8 to be minimum over here. Okay. So you say something like min is equal to array of 0. You assume this number to be minimum. Then you start at the first index. You say for I in range 1 to len ARR, and you check if ARR I is less than the minimum, meaning the array I have found, is it less than the minimum number that's there? For example, is 5 less than 8, everybody? Is 5 less than 8? It's a very easy question. 5 less than 8 or not? Yes. Okay. So if 5 is less than 8, what I will say is my minimum number is now this number 5. Okay. Then next I go to 1. 1 will be compared with my current minimum. What's my current minimum right now? 5. Is 1 less than 5? Yes. So my current minimum becomes 1. Okay. Then 7 will be compared to current minimum. What's the current minimum? 1. Is 7 less than 1? No. So current minimum stays 1. We are not updating it. This condition is never satisfied. 3. 3 is compared to what's the current minimum? Current minimum is 7. 3 is compared to 1, which is the current minimum. Is 3 less than 1? No. So we don't swap or we don't update. There's no swapping here, it's updating. 2. What's the current minimum right now? 2 is compared to 1. Is 2 less than 1? No. So we don't update it. This is how you find the minimum number. Okay. Let's say next step. I tell you, I don't want the minimum number only. I also want the minimum index. So what I will say is minimum is array of 0, and I'll say, let's say index is equal to 0. Now, when I find the minimum number, I also want to find the index. What change I have to make here? Where should I make the change so that I get the index of the minimum number also? Look at the code. This, if I say print minimum now, it will give me the minimum number. If you look at it on the right side, it should give me 1. It's giving 1. It's giving the minimum number. But I not only want minimum number, I want index of the minimum number also. What change I have to make? Very simple, very easy change. Don't be shy. If you get it wrong, then also no problem. Who was that? Very nice. Round of applause for this. Your name? What's your name? Pradeep. Huge round of applause for Pradeep, everybody. Very, very good. Very good. We said this array of I is the minimum number. When you update the minimum, also store the index. You say index is equal to I. So that I know where this number is coming. Right? So I'll say print minimum, and I can also say print index equals to right. I'll use f strings. So print index is equal to idx. So I know which index also this minimum number is coming. The index is 2. Is this clear, everybody? Do you want me to repeat any part? Is it clear? Louder? Okay, cool. So it's clear for everybody. This is what you call as finding the minimum number. Why we want to find the minimum number? Why we wanted to find the minimum number? For selection sort. So now our small TV show over. We go back to main TV show. Okay. Episode 1 we paused over there. Now let's go to episode 2 of selection sort. So let's talk about selection sort now. You can note this down, by the way. This can be asked in interviews. You can note this down, then we'll go to selection sort. Sure. Yes, sir. Okay. Everybody clear with selection sort? Is everybody clear with selection sort? Can I hear everybody? Very good. Let's go on to the next sort, which is insertion sort. So let's go on to insertion sort here. Insertion sort. Insertion sort also has one of the same logic, only one small same logic, which is in insertion sort, you also have two arrays. Means you have two parts, sorted part and unsorted part. Okay, sorted part and unsorted part. The difference here is you will assume already one element to be in the sorted part. Okay, let's first understand the logic, then we'll go into the code. So what you will say is 8 is already in the sorted part and 1, 3, 7, 5, 2 is unsorted. Your job is to take one element. Your job is to take one element from the unsorted part and put it into the sorted part. Okay. So you're going to take one element 1 and you're going to insert it into the unsorted part. Sorry, you're going to take the one element 1 and insert it into the sorted part. Now, if I'm going to insert 1, should it be before 8 or after 8? Very good. So it becomes 1, 8, 3, 7, 5, 2. Next number that I'm going to pick is 3. 3 I should put before 1, between 1 and 8 or after 8? Between. So I'll say 1, 3, 8, 7, 5, 2. What about 7? Very good. 1, 3, 7, 8, 5 and 2. What about 5? 1, 3, 5, 7, 8, 2. And finally 2. 1, 2, 3. Okay. Clear on this part, on the insertion sort part? I'm still hearing a lot of stuff. Shall I take this insertion sort on Friday? Shall I continue this on Friday? Yeah, you can take break today for 1 hour. You want to talk, right? Take break today. I'll just 1 hour I'll take on Friday. Yes or no? Okay. So please silence. Okay. Only talk to me. All right. So we have over here like this insertion sort in this way. Everybody clear on how insertion sort is working logically? Now, how do you actually implement insertion sort? Insertion sort implementation is a little bit tricky. Okay. How to implement insertion sort is like this. You already have the array. Let's say we'll pick up from here, so you'll understand better. Let's look at this part. 1, 3, 8. 1. Let's take this. 1, 8, or let's say this one here. Let's look at this part. 1, 3, 7, 8, 5, 2. Now what we know? We know that 5 should come between 3 and 7. 5 should come there. Okay. But how do we do it? We can use the insert method in Python. That is one way. But again, if you use insert method, you're using inbuilt method. So that is one problem. How you can do it is, you will hold this number 5. I'm just talking about this example. Then we'll do for all of the iteration, all of the process. But with this example, you'll understand better. Let's say I'm holding the number 5. Okay. So I'm holding 5 over here. So this is the number I hold. What you are going to do is, this is the array. That divider is just for your and my understanding. It's not actually there. So I'm holding 5. If any number is greater than 5, I will copy it forward. I am not swapping it forward. I am copying it forward. Meaning, this is 5. Is 8 greater than 5? Is 8 greater than 5? Yes. So I'll take 8 forward. Now you'll say, sir, there are two 8s. No, don't worry. We'll come to that. So I compare 8 with 5. Now I'll compare 7 with 5. What? How can I compare with 5? We are already holding 5. That's why we'll compare with 5. I'll compare 7 with 5. Is 7 greater than 5? So copy 7 forward. Is 3 greater than 5? No. So don't copy 3 forward, but in front of 3 you place 5. Okay. So what we did, basically we hold a number, all the numbers greater than it, we are just copying them forward. The moment we find a number lesser than it, we say, okay, you don't get copied forward. Right next to you, I'm going to put myself. Okay. Same way, let's look at 2. Okay. So now we have 1, 3, 5, 7, 8, 2. And what we are holding? We are holding 2 right now. Is 8 greater than 2? Yes. Copy it forward. Then we'll go to 7. Is 7 greater than 2? Copy it forward. Is 5 greater than 2? Copy it forward. 3 greater than 2? Copy it forward. Is 1 greater than 2? No. Meaning next to it is where 2 should come. So this is how we are inserting something. We are actually not inserting something, we are copying it forward. Okay. It's like saying each of the rows, I tell you come one forward, you come one forward, you come one forward, and then one of the rows I say you wait. Somebody is entering, let that person enter and sit. Understood the difference? Right? So if we want the new person coming sitting right in the middle, one way to do that right in the middle is you tell that person to sit in the middle and tell everybody else to go forward. What we are doing here, we're telling everybody else come forward first, right? And then there will be one space empty. At that point, we tell them go and sit. This is what we are doing over here. Understood this part? So this is how we are going to apply the insertion sort, which means that let's see how to do it here in the code. Go for insertion sort. So I'm going to start at holding the number which one? 8 is already in sorted half, is what I said. So which index do I start from? Very good. I'll start from index 1. So I'll say for I in range 1 till n. Yeah, I'm going to go to n minus 1. So I'm going to stop at n over here. I'm holding the number array I. This is the number I'm holding right now. Right? And what I want to do is I want to keep checking behind. So the difference here is I'm going to go behind and check if the numbers are greater than my holding. If they are, I'm going to copy it forward. So what I'll say is when I'm going behind, I'll say j is equal to I minus 1. I want to start here. Okay. And I'll do while j greater than equal to 0. I'm going to use a while loop. So I'll say while j greater than equal to 0, if array of j is greater than the number I'm holding, whatever number it is, if it's greater than the number I'm holding, I should copy it forward. So I'll say array of j plus 1 is equal to array of j. Copy it forward. In the next one, copy it forward. And then do j is equal to j minus 1, go back. Okay. And see, compare it to what? Compare it to my holding number. If it's greater, just copy it forward. Now once, okay. And if it's not, let's say if array of j is not greater than my holding number, then what should I do? I'll say else break. I've got my point. I've got the perfect place. Meaning here, when I inserted, let's say for example 2, right? If I just go back, when I'm trying to insert 2 over here, I got that 1 is not greater than 2. So this j, you should stop here. J is 0. J plus 1 is where 2 should be inserted. Okay. So I'll say when I'm breaking out of this, when I'm breaking out of this, what will I say? Okay, whatever j that I'm at, that is the j where it is lesser than my whole number. Means array of j plus 1 should be equal to whole. The immediate next number should be equal to the whole number that I have. Okay. Then I go to the next whole number and again try to insert it in the right place. We'll print now. Okay. 1, 2, 3, 5, 7, 8. This is what we call as insertion sort. We can write it down. Insertion sort. Everybody written? Yes, clear? Insertion sort? Okay. So these three are the three basic sorting algorithms. Okay, these are three basic sorting algorithms that we have. Now we look at merge sort. We'll look in the afternoon session. Okay, so we'll have a look in the afternoon session merge sort. But before we go to merge sort, we need to know one or two important things. Okay, we need to look at some important things. So we'll look at one last algorithm and then we'll continue with merge sort in the afternoon session. Or you know what? Take a 10-minute break. Okay, I'll give you all 10-minute break. It's 11:50. Take a break. Just can talk to each other whatever you want. By 12 o'clock, we'll continue the session. Okay. What happened? Lunch break is at 12. I thought 12:30. So 12 to what time is your lunch break? 12 to 1. Wow. Big lunch break you have. And then 1, what will you do? But EDYST session starts at 1:30. So do 12:30 to 1:30 take lunch break. No? Why? Canteen will close. What time canteen will close? 1 dot it will close. Oh, okay. Very nice. Okay. Okay, all right. In that case, you will all be here sharp at 1, 2, 2 to 3:30. 1:30 to 3:30, but now you're taking my time now, so I will make it 1 to 3:30, no? Okay. All right. So I'll not start anything new. Don't worry. Tell me, tell me this. What are the things you have doubts in, or which questions you have doubt in? I will cover those questions also because we have some more sessions tomorrow also. Please tell me what are some questions you have doubt in, which questions on EDYST platform you have doubt in. Tell me name of those questions so that we'll cover them. If today or tomorrow we can cover them. So please tell me the name of questions. Louder. You can say, don't worry, not to yourself, to me. All questions are clear on EDYST platform. All 100%. If I take test today, you will pass all tests. Then which question you have doubt in? Okay, loops. Which question? Question name. No, all questions are completely simple, clear. Yes. Then name of question.
Close it at 2 with 1 and after session starts at 2.
That's at 2.
2 minutes.
Okay, that's as per timetable.
Yes, sir.
Okay, okay. I'll close in 5 minutes. Bow tie pattern. Okay, very good. But I already covered this one in online session. In online, okay, fine. I'll tell you. Bow tie pattern. What else? Which other question? I am not doing this question now. Don't worry. I'll leave you at 12 only. You tell me question name. Which question you have doubt in? Sky full of diamonds. Okay. What else? Which series? Fibonacci series. Others? Others? That's it. Only this question. All other question, if I give you test, you will pass. Then which question you have doubt in? You can't say all questions. You have to give me name of the question. Beautiful. Parks. Okay. Okay. All right. Everybody give me a quick recap of today's session. Bubble sort. Selection sort. In selection sort, we saw another thing. What is that? Finding minimum value using loop. Then after that, insertion sort. In bubble sort, what happens? Which number comes at the end? Maximum number reaches end. And in selection sort, minimum number reaches start of the list. Okay, clear everybody? Okay. All right, so we'll pause here for today, for now. And I believe as per timetable, we continue at 2 o'clock, right? Let me just check it 1 minute. Okay, so the next, you're right, I had not seen 2 to 3:30. Okay, so please be here at 2 p.m. Either you or which other batch. So 2 p.m. will continue. All right. Okay, everybody, thank you so much. Wait. Please follow his instructions. Okay, on how to leave, please follow his instructions one by one.